Hey guys, today we are looking at 5.6's notes, which is all about graphing two-variable inequalities. So, take a look here in box number 1, some definitions and steps. A linear inequality in two variables is simply a linear equation, y equals mx plus b, or some version of that, but instead of having an equal sign, we're replacing it with one of those four inequalities that we looked at back in chapter 2. How we graph them will be very similar to graphing a line, but then just like in chapter 2, we're going to have to make sure we understand what our boundary should look like, and then also which side or where my graph should be shaded. Because in these inequalities, there's going to be an area of my graph that gives me solutions to my inequality, and areas that are not shaded, which means non-solutions. So the way that we'll graph this, and we'll kind of go back and forth between boxes 1 and 2, we'll start by just graphing, finding 2 points like I would graph my line usually. I can replace my inequality with an equal sign if that helps me to visualize it, but otherwise I can just graph that line as if it was an equal sign. So in box number 2, if we're trying to graph y is greater than 2, we know that y equals 2 is just a horizontal line at positive 2, right? There's no slope, there's no x-intercept, it should just be a y-intercept at positive 2. So I'm going to go ahead and just plot a point here at 2. And I'm just going to put some other point so I can draw a horizontal line, because that's what it should be for that equation, or that inequality, should I say. From here, once I know where my boundary should be happening, I don't just connect it with a solid line, because I do have two different options. Remember, back in chapter 2, we differentiated less than and greater than from less than or equal to and greater than or equal to, with having it either be an open circle or a closed circle back in chapter 2. For this, since it's going to be a line that is my boundary, to make a solid line, I'm just going to graph the line as it is. Just a solid line for a solid boundary. That's the same thing as or equal to. So greater than or equal to, less than or equal to, is going to be just a solid line all the way across my graph. If I want to kind of represent less than or greater than, the open circle in chapter 2 is going to become a dotted line, meaning all of these points along my line are not part of my solution. I'm making a dotted line because that is not included in my solution set. And that's really the distinction. If it's less than or greater than, it's going to be a dotted line. If it's less than or equal to or greater than or equal to, it's going to be a solid line. So here in box number 2, the one that we're dealing with, y is greater than 2, is just greater than, so it should be a dotted line. So I'll grab my ruler, I'm going to line it up, and then across here I'm just going to make a dotted line for my boundary. Still have arrows on the ends. From here, we need to determine where it's shaded. Now, there's two different ways of doing this. The way I have written up here is using what's called a test point. So we're just going to pick a point somewhere on my graph, it doesn't matter where, and we're going to check to see whether it's true or not. So I usually, as long as my line doesn't go through it, I usually like testing 0, 0. So I check to see if I plugged 0, 0 into my graph, or into my inequality, is it true? So if I plugged in 0 for my y value, that is not true. 0 is not bigger than 2. So that tells me that where that point was should not be a solution, so it should not be in my shaded area. So that tells me everywhere up above here should be shaded. All of this area up here should be my shaded part of my graph. And I'll just color it all in. So this should be the shaded part. That is where my solutions are. The other way of doing this, as long as your y is by itself on the left side, kind of in standard in slope-intercept form, if it's greater than, it's shaded above my line. If it's less than, it's shaded below my line. So kind of like how we always looked at it back in chapter 2, where if it was greater than, it always pointed to the direction that should be shaded, or less than, it always pointed the direction that should be shaded in chapter 2. Here, greater than is above, less than is below. But otherwise, you can always use your test point. And that's it. Obviously, we'll start looking at some other ways our equation can be written, and we'll have more complicated things. But that, in a nutshell, is all we have to do. So in box number 3, we've got an inequality that looks like slope-intercept form. So remember, that tells me that my slope is positive 2, my y-intercept is negative 4. So I'll start with that y-intercept at negative 4, plot my point. My slope of 2 tells me I go up 2 over 1. So there's my second point. I'll grab my ruler, line them up as best I can. Since this one is now a less than or equal to, since it was or equal to, I'm going to make it a solid line all the way across. And then shading-wise, I need to figure out whether I go above or below. So now I can look at this and just use that shortcut. It's less than, so it should be underneath, below. But you can also still use that test point. If I plug in 0, 0 into my graph to check to see whether it's true or not, 0 is less than or equal to 2 times 0 minus 4. So I'm just plugging in that point, 0, 0, 0 for x and 0 for y. So that tells me 0 is supposed to be less than 0 minus 4. So 0 is supposed to be less than or equal to negative 4, which once again is not true. So that part of my graph should not be shaded. If it was true, that would be the part of my graph that is shaded. But since it was not true, I'm just going to go ahead. I'm just going to make stripies because I don't feel like coloring it all the way in. But this should be the area that is shaded. All right. Last but not least, box number 4, we've got one that's looking like standard form. So once again, if I wanted to find my points for this, I've got my 2 different options. You could rearrange this so that it's in slope-intercept form to have your slope and your y-intercept. But this is also standard form. So if I wanted to replace this, just so it's easier to visualize for us, replace that inequality with an equal sign. And then I can just do the boop method. Boop, cover that up. If 2y equals 2, that means my y-intercept is positive 1. So positive 1 for my y-intercept. If I go ahead and boop, cover up my y values, if negative x equals 2, my x-intercept is negative 2. Come on, move, there we go. So negative 2, those are my 2 points. So now I can get rid of all that scratch work there. I'll grab my ruler, line up my graph as best, my 2 points as best I can. Now looking at my inequality, it is back to just a less than symbol, no or equal to. So it should be a dotted line all the way across. Arrows on the end. And then again, my test point, I'm looking here, 0, 0. Negative 0 plus 2 times 0 is supposed to be, whoops, not or equal to, just less than 2. So 0 is less than 2. Now that is true. 0 is smaller than 2. So that test point should be on the shaded part of my graph. So that means I'm going to go ahead and shade all of this area down here. And that's it. That's all we have to do to handle graphing 2 variable inequalities. The homework is down there at the bottom of your notes page, page 271, 4 through 32, just the evens. As always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.